Hello everyone, welcome to the MathTablet. In this session we're having a look at differentiation, in particular the product rule. As the name suggests, the product rule refers to the times when you have your function being a product of a couple of other functions. So let's say f of x times g of x. Now the product rule states that the gradient function then will be given by f dash of x times g of x plus g dash of x times f of x. Now to help ourselves remember that, we can think of it as the derivative of the first times the second plus the derivative of the second times the first. Okay, so let's see how this works in an example. Let's say we're asked to find the gradient function or the derivative dy dx if y is equal to x squared plus 5 multiplied by x take 1. So really I've got a product of a quadratic function and a linear function. Well, dy dx then will be equal to, let's see, the derivative of the first, which is the derivative of the quadratic there, is 2x, and then multiply by the second function exactly as it is, plus the derivative of the second function, so the derivative of that one is just 1, and then multiplied by the first function exactly as it is. Now a lot of the times you can leave your answer as that. That's because you're not asked to simplify it. Of course, you're welcome to simplify by expanding those brackets and collecting your like terms if you are asked to do so in particular. If you're not asked to do so, you can leave your gradient function precisely as it is. Just by writing that out, you've actually demonstrated that you know how to apply the product rule. Now, the product rule can be used for various functions as well. So I want to just show you this particular one. So let's say I have to find the gradient of y equals 2x minus 9 all squared at the point 0 and 81. Okay? So first of all, notice that I actually do have a product rule situation, because the 2x minus 9 all squared is actually 2x minus 9 times 2x minus 9, isn't it? Which is actually the product of a couple of linear functions. So that enables me to work out dy dx. So derivative of the first, which is 2 times the second, plus the derivative of the second, which is 2 times the first. So I end up with this. Okay. Now, sure, I could have expanded out the perfect squares, collected my like terms, and then differentiated. But herein lies the power of the product rule. It can be done quite simply without all that expansion prior to differentiating. So here I have already the gradient function. Now, just looking at the question again, we're actually asked to find the gradient at a particular point. So what we want to do here is to work out dy dx at x equals 0, which is the x coordinate of the point that we're given. So that's going to be 2 times negative 9 plus 2 times negative 9, giving me a gradient of negative 36. Now we can just double check our answer on the class pad. So bring up your class pad, bring up the keyboard, go into 2D and calc. So there's that dy dx feature, putting x there, in my brackets, put in my function, which is 2x minus 9 all squared. Now I want the gradient at a particular point, so remember we hit option, the vertical line, and we solve x equals 0. And there we have negative 36. So we've just confirmed our answer on the class pad as well. I hope you have enjoyed this session of the MathTablet.